If you're like me, you think about your mass a lot. My mass is usually higher than I would like it. Remember back in week 2, we were talking about the difference between mass and weight and the big G word, gravity. Well, the big G word's going to come back this week in week 11. It's going to come back really strong because we're going to be talking about the evolution of stars from their birth to their, let's say, late middle age. Yeah. So if I'm going to get the mass of a star, I'm not going to use a scale balance, right? And it won't really fit. It'll burn the scale. Very impractical. So how do we get the masses of stars? Remember, we were talking about binary stars last week, and that gives us a great way by using Kepler's third law. And mass is really important when determining how a star is going to turn out. If an object is on the track to become a star and doesn't have enough mass, it's not going to make the cut. It's not going to make the team. It's going to be what we call a failed star or brown dwarf. And if it tries to get its act together with too much mass, well, it's just going to blow itself to shreds and never become a star. What a waste that is. Now, over the course of a star's life, as it's converting hydrogen into helium, its chemistry is changing. Its interior is changing. And those changes in the interior of the star are going to make themselves known on the exterior of the star. So as we look at stars in the night sky and look at how different they appear from each other, we can figure out what's going on the inside, what stage in the evolution of the life they're in. And so what we do is, remember that we have the HR diagram, the Hertzsprung-Russell diagram, where we plot the location of a star based on its luminosity or true brightness versus its temperature or spectral class. And over the course of a star's life, it's going to move on the HR diagram. It'll spend most of its life on the main sequence, the happy, healthy part where it's converting hydrogen to helium in its core. And then when the core converts all to helium, well, let's say bad things happen inside. And the outside of the star is going to respond to what's happening on the inside of the star as well. So this week we're going to be talking about things like red giants. Now, a question that people will often ask is, what will happen to the Earth when the sun becomes a red giant? Well, think about it. When the sun becomes a red giant, it's going to swell up and it's going to swallow Mercury. It's going to swallow Venus. And astronomers aren't quite sure if it's going to swallow the Earth yet, but even if it doesn't technically swallow us up, it can't be good for the Earth to have the sun swell up so much that it's almost in our face. So, yes, the Earth has an expiration date, and it's going to come before the actual technical death of the sun. But enough of that cheery thought. As you go through the material this week, you're going to find that at various stages in the life of a star, there are lots of things going on simultaneously. So really sort of take it step by step. At each stage in a star's life, ask yourself, what's happening on the inside and what can we observe on the outside? And look at the HR diagram and try to put it all together as a puzzle. Maybe write yourself a little story about what you think is happening on the inside of a star and how it's manifested on the outside of a star. Find a young person or someone who knows less about astronomy and try to explain it to them, because we learn best when we can teach it to others. So hopefully this chapter won't scare you too much, or this week won't scare you too much when you think about the eventual death of the sun. And again, if you have any questions, let me know.